Good afternoon, everyone. My name is Chien Huang. I'm an assistant professor in the Department of Computer Science at Hopkins. So today I want to talk to you about two things that I like a lot. One is robots, the other one is people. So essentially, I'll give you some examples of human-robot interaction projects that we do in my lab. So as you may know from online social media, you will see a lot of robots that are coming out of the lab and into our daily environments, right? So over the years, we have seen, if this works, all right, we have seen robots being a part of very highly professional context, right? So we use robots as tools to perform various surgery, right? So this kind of robots are very expensive, highly precise, but then more or less are teleoperated by human experts. We also see robots become more autonomous, right? It becomes an autonomous tool. Where example here is robots in warehouse. Robots are moving autonomously, picking up and prepare packages for customers. So you start to see this spectrum of passive tool to autonomous active tool. Another example of autonomous tool is in manufacturing. Only if my slides works. In manufacturing. Car manufacturing is pretty much automated right now. This is a scene for car assembly, right? So if you look at this, those robotic arms are fully autonomous, move very fast, very precise. And if you see this, there is only one person, one human in the picture, right? So that person stands there. Right, so there is no interaction at all, right? The person stands outside of the cage of the robot farm, just monitor everything, but there's no close interaction or collaboration. But we are moving away from this paradigm of fully autonomous automated process. We are moving toward more collaborative process where people and robots are working together side by side. And this is particularly useful and important for small and medium-sized manufacturing companies in the US and around the globe, right? So because of the product cycle is becoming shorter and shorter, people want stuff that are customized, right? So traditional fully autonomous manufacturing floor doesn't make sense anymore, right? So we're moving toward more collaborative process where we can adapt as we go. And this kind of human-robot collaboration goes beyond just professional environments like manufacturing. It goes into like hotel, supermarkets, hospital, right? Start to see robots entering, and these are actually real examples. This is not just like stage up pictures. So these are actually deployed systems in our society right now. And robots even coming closer to home environments where it provides elderly care, educational support for young children, various patient cares, and even help with people with disabilities. So this is sort of the landscape that's going on right now in the community of robotics, where we start to build robots that can interact, that can collaborate with people. And specifically, this is the field we call human-robot interaction, and this is the research community that I mainly associate with and work in. So we care a lot about technology. Obviously, we also care a lot about our users, which are humans, right? So how can we design robots, robotic technology that can better serve humans in general, such that the interaction is intuitive, effective, and also productive. So today I thought I will give you some examples of HRI, human-robot interaction projects in my lab. The first example I'm going to show you is this coordination idea, right? So when you think about human and robots working together, they need to coordinate their actions. So I will use this dish unloading as an example, right? So we study how people do this kind of coordination task. And then we build a model around it, implement it on the robot, and look at human and robot working together as a team. So to understand this action coordination, we actually have people come into the lab to do this task. So it's very common task that you unloading dishes from drying rack, right? So you have one person pick up a plate, pass it to another person. That person places the plate to the cabinet. We also manipulate the receiver's task load, and the goal here is to see how the giver adapt to the receiver's action. Right, so here's an example. To pass the plate, the receiver needs to match the plate to a specific location, therefore slow down the receiver's action. And you see the giver actually adapt his action to the receiver. So we collect a bunch of data like this. We model it. I won't go into detail, but then we implement this into a robotic system. And we evaluate what it will be like when the robot use our model when interacting with people. So before I show you our model, I want to show you two baselines. The first one is what we call proactive robots. Like the robot doesn't care about the human's task. The robot just wants to finish its own task. Right? So it's very proactively preparing the next task. So here we have very similar setup. You have a human receiver, you have a robot giver. We have 3D cameras and sensors to monitor their current task state. So this is what it looks like. We give the human receiver a secondary task to slow down the human, right? So essentially solving this math problem and match the result to a specific location. And it's actually pretty hard if you want to solve this on the spot. And here you see that the user, the human, was pressured by the robot and then end up give up the math problem, right? So this is the kind of cooperation that we don't want to have between humans and robot. We don't want people to feel pressure, to feel forced by their robot partner. So obviously this is not ideal. Another baseline you can do this is more like a passive robot, essentially like turn taking. I do my part, you do your part. When you finish, I'll do my part. Right, so similar setup, the person finally solved the problem, the robot detects it, and then move on to do its part of the task. It's very safe. The only downside for this paradigm is the human needs to wait. Right? Essentially, you need to idle and wait for the robot to do its part. So this is not bad, but it's just like a little bit less efficient. So what I'm going to show you is what our model after the human-human collaboration, what we call adaptive robot, right? So it's the same setup. The person is working on the problem. The robot recognizes that and slow down its motion. And as the person continues to work on the problem, the robot eventually stop its action and wait for the person to finish. As the person finish up the task, the robot present the play for the person to do next. Right. So here you see the person, the human was very confident about the handoff from the robot. Right. He was not even looking at that handoff. And this is the kind of collaboration, coordination that we want to have between humans and robots. All right, so this is one example of human-robot collaboration, and you can see this as potentially in the future at home, you have home care robots that can hand you your TV remotes or something. But this kind of low-level coordination is sort of the fundamental building block for a lot of HRI applications. But if you look at this kind of robotic assistant, it's very complex to create, right? So in order to build a system like that can work alongside with humans, it takes a bunch of dedicated engineers, students to just work on the perception, work on planning, work on the user studies. It's just like not very scalable, right? But if our vision is to have robots in people's home to provide individualized assistance, at some point we need people, end users, to be able to customize their robot assistants, right? So this is where we started to think about end user robot programming. How can we let end users, people who may not have technical trainings or programming experience, to be able to quote unquote program the robots to do what they want to do? And turns out this is very difficult, right? So robot programming is very difficult. One easy way is to allow the people to drag the robot's arm to show the robot, to provide demonstration to show the robot how to perform certain tasks. For example, how to hang the tower, how to do pulling, how to do pick and place. Even with this kind of hand demonstration, moving the arm directly, it's still very difficult, right? Most people have difficulties when providing demonstrations. So we start to think about what else can we do to make the barrier of programming much lower for everyday people. So we start to think about maybe you can do illustration, right? So if you think about our interaction with mobile phone, right now it's very touch-based, right? So we are very good at swipe, zoom in, zoom out, to use gestures and illustrations to tell our mobile phone what to do. So what if we can use this kind of situated illustration gesture to provide instruction to robot to tell them what to do? That would be much easier for everyday people who may not need to know how to program. So we look at this, right? So we essentially build this augmented system to illustrate this idea of using touch-based interaction to tell the robot what to do, right? So example here is very simple, pick and place. The user will will circle an area, say here is the source object, here is the destination area, and then put an arrow between them to tell the robot move objects in the source area to the destination area. So no need to write any code, but just provide illustrations to instruct the robot. So it worked out fairly well. Most people are able to do it just because it doesn't require a lot of logistics thinking, just based on gestures to be able to specify the tasks. But then the limitation of this kind of illustration is it only works for tabletop setting, less complex tasks, right? So what if we want the robot to be able to help us with more complex interaction, such as assembly, right? You want to assemble your IKEA furniture like a chair. That would be very difficult to illustrate on the table. So we look at another direction into end user programming, and this time we look at this idea of first-person demonstration. So the idea is that as a user, I will provide demonstration of how to do the task first, and then the robot will pick up the model, how to perform the task, and then provide assistance the next time. Right, so here on the left, you have the person wearing this head-mounted camera to capture this first-person view of how I do the task. And then we essentially create the model of how to, in this example, how to create a chair, how to build a chair, and then translate that to a robot assistant. And the robot will then be able to help with the user through this first-person viewpoint. So this to show you what it looks like. This is the demonstration, right? So with a head-mounted camera, the person essentially just build that chair as if she would do it. And then from her first-person view, this is what it looks like. Right? So the robot essentially can channel to the person's first-person perspective to understand how the person assembled this IKEA chair. So with this information, we build a model to create a task of the chair, when to use what piece, how different pieces are fit together, and all that. Like what's the best angle to present the object. And then we translate that to a robot for assistance.
Please screw the two parts together.
So this is when the robot used that information, that pre-trained model, to help with a set of new users. And we found out that with this pre-trained model, people can collaborate and work with the robot much more efficiently and productively. So essentially, this is another way to do end-user programming. So think about this, and if you want to do something for your grandparents, you go to their house, you provide demonstration, and the robot can do it the next time for your grandparents. So that's the idea, to allow everyday people to be able to provide task demonstration, to be able to provide task specifications, such that their personal robots can provide a better service and assistance to them. So there's a lot to do in this space as we see more and more robots coming out of the lab into the human environment. We need to think about what else we need to build into the robotic system, such that people feel comfortable, people feel confident and safe working alongside those robots. There are other type of work that's going on in my lab. If we have time, I'll be happy to talk more. But I want to give people enough time to ask questions. So with that, thank you for your time, and then I'll be happy to take questions.